Hey guys, in this video we're going to code a command line snake using Python. So I've just got a Python 3.5 virtual environment set up, and I'm thinking we're first going to need a board width, a board height, and let's just set that to 15 to begin with. We're also going to need a board. Let's make our board using this nice Pythonic way of doing things. I think that should work. So this creates a column. This whole line creates, a row of hashes, and then this repeats that row board height many times. So we'll end up with a 2D array. Let's just, hopefully that works. I'm gonna just go Python and spell your variable names correctly, and it's printing a string. Okay. It's because that needs to be there. I was making a 2D array with these massive strings. It's not what I want. I want that. Yes. Sweet. Now I want a way of keeping track of my player. So everybody knows snake. You're a 2D snake, like of blocks. That's a really gorgeous snake. And you move around, and then you eat apples. Let's just call this an apple. Okay, so we need to keep track of a player, which can just be a 2D array of, let's call them X, Y positions. So 2, 2, 4, like, and then we need a way of keeping track of the apples. We'll just say 3, 4, so it's very close, or 4, 4. Now we need a classic while true game loop. Every time we go through, I want to print the board. I'm just going to make a nice board function. Def print board. And I also want to go through my player, all the body parts of my player, and update the board. So we will set that to be our player. So we'll just make an @ sign for our player. And what do these indices need to be? So these are X, Y positions. These are X, Y positions, but this board, first, to index this board, you need to specify a row and then a column. So say 2, 4. I want to say at 2 and then 4. Whereas if I just go 2, 4 here, right, then that will, if I just said board 2, 4 equals that'll actually go row 2, column 4, and it'll set that. So it'll kind of be mirrored. So basically, I need to go P1 and then P0. So I need to flip those. And do the same for every apple. Actually, let's just copy that. And we'll just set our apple to be a $. and then we want to print the board. Actually, I'll just make a prettier way of printing the board, so I'll just call it display equals an empty string, and then for every row in board in range board width, so every row, and then for every column in range board height. Oh wait, I got that around the wrong way. So I want to add to the display the board at that row, and then that column, and then at the end of every column I want to add a new line. So, and then I want to print the display. Board is not defined. Oh yeah. So it's treating each row as the same object here. So we actually need to use, I'm just going to use deep copy. So import copy. And I'll just use a list comprehension. So that should do the same thing, except, wait, I need to actually use copy.deep copy for I in range of that board height. Then, sweet, yeah. So we're just printing the board. I'm just going to import time so we can sleep every game loop. Time.sleep. Let's just sleep for 0.2 seconds. Alright, now I need movement. So I'll just go and move, equals input, and then if player moves and they press A, what does that actually mean? Okay, we need to keep track of a direction that the snake is moving in. So that if they pressed A, then we want to change that direction. So let's make a direction variable. How are we gonna, if they want to go, if they press A, that means they want to go left. So what's a good way to represent that? Well, that means that they want to change their X value by, yeah, so I'll represent it as a vector, and we'll just say initially that, this means that they're going to the right, so 1 in X and then 0. So that means my direction is to the right, and my Y, you could think of it like a velocity. If they press A, then we'll set direction to be -1, because that's left, and then if they go D, they want to go to the right, LFW, they want to go up, so that means 0 in the X, and up in our coordinate system is -1, because we're going up a column. LF move is equal, unless I wanted to add a negative sign to this to this value, sorry, this value here. But anyway, if move is equal to S, then direction can be equal to 0 and 1. So to change our direction, we want to set our players player 0 dot plus equals direction. I'm not sure if that'll work. Let me just print player to see what happens. Oh yeah, see, we just keep getting a direction appended on. So we actually want to do element-wise addition for each component. So 0, 0 plus equals direction of 0, direction 0, player 0, 1 plus equals direction 1. Yeah, I think that should work. See, now a player is actually moving. We don't contact apples yet. And also this is non-blocking input, which sucks. Okay, so we've got movement going. So the next task I'm going to go for is making it so that we don't have to keep pressing enter every time we move. So essentially what we want is non-blocking input. Let's just put me over there. My favorite, this is nice, it's an internal library. Let's just assume that this code works. So this is where it prints out, this is the callback. Went to D, so I still keep having to press enter. I mean, it's non-blocking, but oh, it's because I got that there. Oh yeah, I need to comment this all out. Okay, so yeah, I need to press enter. How do I get a single character? Read char. None of these look nice. That looks nice. Get char. And can I just literally just put get char here? Okay. I think it actually could be working. I just need to actually change. So let's just change this to move. Oh yeah, so I think it's working with a local direction, so I need to make direction global. Do I need to add global down here? Sweet, that's working. One thing I want to fix is I don't like how the board is really tall, so I'm just going to add a space there. Now we need to deal with when we eat an apple, we grow in length. So let's just do a check. If eat apple, player and apples, and then let's define this function def eat apple if player. So we just want to check if the head. So we're just going to assume that our head is the first entry in this 2D array. If the head is in any of the apples, meaning if its value is the same as any of those apples, then we'll return true. Otherwise, return false. And what you may notice is that, yeah, that's just the same as returning that without that colon there. So if we need an apple, what do we actually want to do? This is probably the hardest part of the logic. So if we eat an apple, then we grow by length 1. So that means I'm just thinking, say if we're here and we eat an apple right where we are, then I want there to be, in the next frame after this, I want there to be everything's gonna shuffle up and follow the head. We still need to do that, but I want this last tail piece to linger behind. So the way I'm going to do it is I'm going to go player equals player plus player, the tail, -1, that gets the last piece, and then I'll copy that. Copy dot deep copy player. Okay, I think I need brackets around this. Oh yeah, so what's happening is every time we hit the apple, it's adding on the value at that point, which is 3, 4, and then the apple's being drawn above it, because it's being drawn last, so it's overwriting it on our board display. So what we actually need to do now is code. I'll just first draw the apples first, so that a player takes precedence on the display, essentially. And then yeah, that was really quick, but the apple was there. Yeah, you can barely see it. I should move my player to row 2, 3. Yeah, see, so as soon as we hit it, we have a tail position there. So now we need to think of how to code keeping the rest of the body following the head. Okay. So let's just say this is our whole body. And we say that our direction is left. Okay, so first up, we want to move our head, and then we want all these to shuffle up one. So I could do a loop that loops over, that first moves this position, or the first shuffles all these up. That's easy. So that's one way of doing it. Another way of doing it would be to make a copy of the head. So this can be a copy. Move that copy in the direction we're going, and then just delete the last tail. That would save us shuffling everything up, because it's pointless to shuffle everything up because we already know where everything's going to go. And this will create the illusion that the snake's moving. So let's just try and code that. So if so player equals player 0. So copy of the head. So copy the head and add it to the player, right? Then we'll move that copy, as we said. So this is this part here. Move the head, and then so that's moving the head, and then we should just be able to delete the last player. Int object is not subscriptable. Oh yeah, I did that same error again. Sweet. That just works. That was way too easy. There are a lot of other ways to do it, I'm thinking. But that is really fairly elegant. I'm just trying to think of another way to actually maybe make this a little bit more efficient. So we delete the last player all the time, and we're copying the last player here. So doesn't that just nullify that whole step? So we don't actually have to do that. It's only if so it's only when we haven't eaten an apple do we delete the last one. Does that make sense? So if we don't eat it, if we haven't hit an apple, then we'll keep moving. Whereas if we have hit an apple, we'll keep that tail so that we grow. Hopefully that makes sense. Oh yeah, this is this should just probably go after this because it's getting caught. Yeah, it's working. That's sweet. And then else, so that means we have eaten an apple. We want to, let's just go score plus equals 1, so we're going to need to make a score variable, and then we want to go apples equals make new apple. Let's just go apples, let's just work with one apple for now. Def make new apple, return, so import random, return a between random.rand int between 0 and board width, so that's a x, random.rand int between 0 and board height. So let's just score equals 0. We'll also print score plus score. Yeah, so every time we collect an apple, it appears at a random position elsewhere. It's working. The apple's being assigned. Oh yeah, this is a bug. So I need to. It's going out of bounds. This is an exclusive. This is randint from this to this. Inclusive. Sorry. So it'll go to the board height -1, which is the last possible index value. Yeah, this is basically just working now. What are some other features? I want to make it so you die if you hit your body, if you die if you hit the sides. So let's just do that. Check bounds. So def check bounds. So if the player, if the player's 0, if their head x value is less than 0, or the head's x value is greater than the board width, or greater than or equal to the board width, or the head's y value is less than 0, or the head's y value is greater than or equal to board height, then we want to just go print died as left board, and then go just quit. Okay, so let's check if that works. Check bounds. Oh, yeah. Use correct Python conventions. Check bounds. Oh, yeah. Player. Seems like it was delayed when it. I think there's a bug here. So say, are we getting list? Yeah, there's a bug. Greater than or equal to board. Oh yeah, we should check the bounds after we move it. Because it's moving in that direction and then it's trying to draw it when it could be out of the bounds. So I think of this as like a render, because it's drawing like game data to the display. Bada bing. Oh my god. Bada boom. Yeah, so that's working. Now we want to check body collision. So we die. We die if we hit our body. So if our head is in the rest of our body, then we'll do a similar thing here. Died as hit body, quit. I think that's right. Yeah, so this means the player, the slice of our list from 1 to the end, that implicitly means to the end. Yeah, so let's just try and get 3 length. Yeah, died as hit body. Another thing is I don't want to be able to move back in the same direction we're already going. So if move is equal to A, so if we try to go left, that means we shouldn't already be going right. So that means if move is equal to A and action is not equal to going right, then we can move left. W, then, so if we want to move down, then we shouldn't be going up. If we want to move up, then we shouldn't be going down. So if we want to move down, then we shouldn't be going up. And that should hopefully work. Yeah, I can't move in that direction. Okay. Finally, I want to add, just to pretty up the game, I want to add emojis. Python emoji. So emoji, there's an emoji package on Python. I only recently just found out about this. It's quite cool. Emoji cheat sheet. So we just import emoji. I don't know if I've got emoji installed. Yeah, I must have emoji installed. Oh yeah, I've installed it at Python 3.5. Okay. So let's just make like sort of rainbow. That can be our background symbol. So instead of a hash, it's just a rainbow. For the snake, we'll just make it a snake. I think that you can just use snake, and then for apple, we'll just make that a cookie. These are just pretty standard emoji names. And then when we print the display, we need to go emoji.emojize. Emoji.emojize the display. So let's see how that looks. Oh, sweet. It looks pretty decent for a command line game, for a console game. So it's a little bit difficult. Well, I'm just bad. yeah, I want to get rid of printing what I entered because that's messing up the nice display of our game board. Yeah, that's much better. Awesome. Well, thanks a lot, guys, for watching. The code for this game will be available on my GitHub. The link will be in the description. I'm Storm Bartlett, and thanks for watching. Have a good one, guys. Cheers. Also, just noticed I should probably rename this is head on Apple, just to be more clear, because it returns a boolean and doesn't actually really do anything. Callback. Alright, sweet. Yeah. Alright guys, thanks for watching. Hopefully you guys enjoyed this, and yeah, subscribe for more. Comment what you'd like to see next, coding or otherwise, from me. This is my first video, and I'm looking to try different things. So